Scientists always have to be very careful when they find what they're looking for. When we go out and we search with our big telescopes, like your giant telescope, the GTC on La Palma that we saw yesterday, if we actually find the thing we're looking for, we have to ask ourselves, have we gone astray? And I'll give you some examples in my own field of astroseismology. We're very closely related to the search for planets by using the very precise timing that we get for stars that pulsate. They're like perfect clocks. And the very first planets that were ever discovered around another star turned out to be a big mistake. What the person actually discovered was the Earth. And it's because the timings were just a little bit wrong. We had corrected our times not to be on the Earth because the Earth's moving around the sun, but to a place in the center of the solar system where all the gravity of all the planets in the sun balance. And then another case of that, a supernova blew up in 1987. I saw it when I was living in Cape Town. I could just walk outside and see it. It blew up in the Large Magellanic Cloud. And about a year later, astronomers observing in Chile discovered a pulsar, a rapidly spinning star at the center of that supernova. They were looking for that. Very precise clock, but this one was spinning so fast it couldn't hold itself together. And the theoreticians, the physicists working on this, rushed out and they found ways to change the physics so this star became possible. Until the next year when the astronomers went back and discovered the signal they had found was in fact in the television camera they were using for guiding on the star. And so we always have the potential for making mistakes like that, but we know we have to be careful. We can go wrong, and we always question ourselves, what if we're wrong? What if that's not right? What if we've had a pitfall and fallen into some trap that we didn't see coming? Interestingly, Europe leads optical astronomy. They lead North America. They lead the United States. The building of the big telescopes like the GTC, the 10.4 meter telescope here in the Canary Islands, are part of that leadership of Europe. And Europe has been leading in astroseismology, the study of the insides of stars by studying the way the sounds cause the stars to vibrate. Recently, with the launch of Kepler in 2009, a mission to look for planets like the Earth around other stars, but also to study the vibrations of the stars, you might think that that leadership could be passing back to the United States. It was a $600 million mission. But the US is concentrated on finding the planets, and to do the astroseismology, they actually got us Europeans to form an institute called the Kepler Astroseismic Science Consortium, and Europe continues to lead that. The Americans participate, but Europe still leads. These winter schools, these astroseismic schools, astronomy schools, are very good ways to bring together students from around the world. And one of the important things that does is it gives us connections for life in terms of doing our science. This works both ways. I'm meeting some very, very bright students at this school, and they're not just my future colleagues, they're my future leaders in the things that they're expert in. And that's certainly been true of students I've had in the past. I think it's very important for scientists to give back to society. As an astronomer, I'm a very fortunate person. If I didn't have to work for a living, I would hardly change anything that I do. But all of the funding for that, for my salary, is not the big deal. The big deal is for the €1 billion European extremely large telescope we'd like to build, for the very large telescope in Chile, which I observe with, European project. We cost that at €50,000 per night for the telescopes. All of the money, the funding that comes from that, comes from the public, comes from you. And you deserve something back for that. You deserve to get to know what it is we're doing with the money and why it's interesting. We're lucky in astronomy that the public's interested in what we do. Some years I do as many as 50 public talks, and it's because I like to teach. I mean, I teach at university too. If you like, I like having a captured audience that's mine for a while that I can talk to. I've been an observational astronomer essentially all my life. I started as an observer when I was an undergraduate student in San Diego, California, where I grew up, and fell in love with just going to the telescope, spending nights out at the telescope, looking at the stars, discovering new things about them. One of the reasons I moved to South Africa was the opportunity to go observing frequently, and for more than 20 years I was at the telescope at least a week per month. And so it was just a normal part of my life to be out in the dark, in the cold, observing the stars and see what they do. But my life has completely changed now. With the Kepler mission, with the Corot mission, with the space telescopes we've got, For the kind of thing that I do, looking at the way the sounds cause stars to vibrate and using those vibrations to see inside the stars, with the space missions now we can see 1,000 times better than I could see when I was a young man. And anytime you get vision that's 1,000 times better than you had before, no matter what you're looking at, the discoveries just come pouring out of it. What that does mean is that all of that work that I did for 20 years at the telescope in South Africa is now completely obsolete. It served its purpose at the time, we made the discoveries, but we'd never do it that way again, we'll never go back to that. It's like photographic plates. Unless you're a specialist hobbyist, you wouldn't get a camera now and put some film in it to take pictures, you're going to take digital pictures. And the same with the kind of work I do. I'm not going to go to the telescope and look at one star at a time for a few hours and then the sun comes up and the rain comes. From space we can see so much better. It doesn't ever get cloudy, it doesn't get rainy, we can watch continuously. And with the Kepler mission, for example, we're looking at 150,000 stars simultaneously. On the ground I watched one at a time. It's an utter change in my life.